Looks like everybody's wrapping that up, so page 154, you'll notice continuing to use functions notation, not surprised when the unit is functions, that we are going to continue to talk about them, to describe rules. Part 1 today, part 2 tomorrow are going to be very similar. So take a look at the first tables there. Two separate functions, one on the left, one on the right. What do you notice? What do you wonder? Anybody got something they notice that they'd like to point out?
There's a different equation.
There are different equations, different functions. Yeah, one's f of x, one's g of x. Certainly doing two different things. Okay, how do you get those answers?
By solving it?
Well, it tells you what x is. So 10 minus whatever 2 times x is. So 10 minus 2. If you plug in 5, it's 10 minus 10. Okay, so the first number here, it doesn't tell us, but that's the input. Independent variable. Second one is your output, your y. The same thing is true for the next table. Negative 2 cubed, 0 cubed, 1 cubed, 3 cubed. This is what we're inputting. This is our output, dependent variable. One on the right depends on what x is. When you slide into part 4.2, there are 4 descriptions and there are 4 functions. All have a 3 in it. All have an x in it, all have a 7 in it. You'll notice the order is super important. Are you dividing by 3? Are you multiplying by 3? Are you subtracting 7? And then what order do you do these things? So I'm going to give you about 2 minutes to see if you can match the equation with the correct description. Order is super important. So see if you can match those. I'll give you 2 minutes.
Is next Friday our last day in school? The 17th? Or the 16th?
16th, last day of the year.
Let's go.
Got about a minute left.
No, I couldn't beat people. Watch me doing that.
All right, Georgia, let's hear which one you got matched with f of x.
Could I do all of them or just?
Just the top one.
Okay. C.
C. Multiply by 3 and then subtract 7. That is C. G of x. Caleb.
I don't know, A.
B.
You are not dividing by 3 in
I thought
G.
you're multiplying the 3 into the x minus 7.
Yep, but A says subtract 7 and then divide by 3. B, subtract 7 and then multiply by 3. So that goes with B. D, divide by 3 and then subtract 7. And that leaves A. Again, order, super important. Question 2 on top of the next page says if you plug in 6, you get -3. Which one works? Well, let's just start with the top one. Let's plug in 6 and see if we get -3 for an answer. 3 times 6
18,
minus 7.
11,
Not -3. Let's try this one. Goes in for x, remember. 6 minus 7
-1,
times 3.
-3.
-3. So your answer is G of x. It does say y. Well, if I plug in 6 for x and solve it, I get the output it was looking for, which is -3. All right, it says for number 3, if I plug in 0, which answer is going to give me the biggest answer? So if I plug in 0 for each letter,
Which is gonna be the what? Biggest number? Oh.
biggest. All right, so if I plug in 0 for x on the first one, what do I get? -7. If I plug in 0 for x on this one,
Like -20.
what do I get? Zero for this one.
-7.
0 divided by 3 is 0. Minus 7.
-7.
And 0 for this one.
-7/3.
Okay, so I wrote all 4 answers down.
Okay.
Want to know which one was the biggest? They're all negative.
Okay.
So K would be the biggest. Then it says, how about if you change the input to 10?
It's F.
Well, if you plug in 10 for the first one, what do you get?
23.
3 times 10 minus 7. Okay, somebody else answer the next one. Plug in 10 for x on G. What do you get? 9. 10 minus 7 is 3. Times that outside 3, you get 9. How about if you plug in 10 for h of x? 10 divided by 3? 3 1/3 minus 7. That's going to be negative 2/3. And the last one, plug in 10. 10 minus 7 is 3 divided by 3 is 1. So the one with the greatest value is F. Maya says f of x is always greater than g of x for the same value of x. Do you agree with that?
No.
So we did 2 examples here. We did 0. F was bigger than g. We did 10. F is bigger than g.
Yeah.
Will that always be the case?
Oh, no, because it could be a negative.
Let's try a negative quick into those 2. Give me a good number to try.
-2.
So 3 times -2
-2.
minus 7.
-13.
-2 minus 7 is -9 times 3.
Negative 27.
Once again, F is bigger. So we tried 0, we tried a positive, we tried a negative. Are you ready to make an assumption?
Yes.
In fact, always 14 bigger. It's actually always 14 bigger than G, no matter the number you try. Okay, so being able to recognize patterns are beneficial as well. Last one we're going to look at, a square has a side length of 9, area of 81. 9 times 9, obviously 81. Given this table, can we write a rule? Well, let's fill out the table first. Area, if the side length is 1. 1 square centimeter. Side of 2? 4. 2 times 2 is 4. 4? 6? S?
S squared.
Very good. What does A parenthesis 2 mean? Well, that means what is the area? With side length of 2. And then, of course, we know that is 4, right from our table. Let's graph it. Georgia, before you turn the page, tell me those points, please.
1, 1, 2, 4, 4, 16, 6, 36, S squared.
And then obviously 0, 0 as well. So you can tell, not linear. Thank you, excuse me. Bigger the side length is, it gets up for an area in a hurry. Exponential. Makes sense because we're squaring it with it, which is an exponent. Would still pass the vertical line test we talked about yesterday, so that is a function. Question number 2. Roll of paper that is 3 feet wide can be cut to any length. If we cut 2.5 feet, what is the perimeter of the paper? So if it's 3 feet and 3 feet, and you go 2.5 and 2.5, what is the perimeter of that? 11. Complete the table with the perimeter. How about if I cut off a foot? Well, it's still going to be 3 feet wide. I only need a foot. Can't see my picture there. Sorry about that. What is my perimeter? Eight?
Yes, it'd be
3, 1, 3, and 1?
Wait, oh, 3, 1. Yeah, I thought you had to cut 1 down to 2.
Would it be 1.5? Because you took 1 out? Or am I?
So it's 3 feet wide. That's not changing. I'm cutting a foot this way, my wrapping paper. So a foot, 3 and 3. That's a total of 8. 3 feet wrapping paper. I'm pulling out 2 feet now. You're just adding the numbers that go around there. 10. 6.3. 6.3. Jackson, what'd you say?
18.6.
If I pull out 11 feet, big present.
28.
28. All right, so what am I doing to the length here to get the perimeter? Well, I'm doubling it,
L squared.
so L plus L, or 2L. And then I'm adding 3 and 3,
Plus
which is 6. So whatever the length I'm cutting off there, I'm doubling it, adding 6 to it. So what does P of 11 mean? Well, that is the perimeter of a sheet of paper if I cut 11 feet off. So it's this drawing right here. If I pull 11 feet off of that roll of wrapping paper, what's its value? We just answered that. 28 feet is the perimeter right from the table. Got it right there. So let's plot those. 1/8, 2/10, 6.3, 18.6, connect them. So how would you describe this graph compared to the other one? Linear. Why is the y-intercept not 0?
Because it's the side,
because you're still gonna have 6 feet no matter what.
Yeah, you're gonna have both the outsides. You're gonna be 6 feet no matter where you cut it.
if it's 0, would it
It's
not?
gonna be 3 and 3. Yeah, I mean, there's one where it wouldn't really make sense. But if you're figuring out perimeter, no matter where you cut it, you got 3 feet, 3 feet. So I guess if you cut it at 0, both parts of your rectangle would be the starting side. 0 by 3 rectangle. All right, your homework. Page 159. Okay, first one matching. We just did one like that. I don't think that's going to give you trouble. Fill out the table. We just did a bunch of those. B, write the equation. Write the function. You know, how are you getting those numbers pretty much? Graph it. 3, you're plugging in 2.5 for x, seeing which one's bigger. Does everybody remember what equilateral triangle means? Same on each side. That should help you with number 4. Number 5, that one should look pretty familiar. We answered one like this on the warm-up not that long ago. Okay, what are the 2 things that you're analyzing when you're filling a pool? One would be time.
Can I get Layton Coleman and Spencer Brown to the junior high office, please?
And the other is gallons of water. Okay, how long you leave your hose run and how much water is in the pool. That's what you're analyzing. One of those depends on the other one. Question 6, multiple choice. Question 7, multiple choice. That's it.